All right, existence and uniqueness to linear first order ODEs with initial conditions. We want to understand, when do solutions exist to ODEs? And if I have this initial value problem, so I have this initial condition y of 2 is equal to -1, when are solutions actually unique? Okay? So the first thing that we want to do is, there's a nice theorem that governs this whole thing, and it simply says, get your ODE in standard form. Okay, so step one is get it in standard form. So what does that look like? That means divide everything through by t squared minus 9. That's going to look like t divided by t squared minus 9 times y is equal to e to the t over t squared minus 9. Okay, so that's step number one. Now, this thing here, whatever this is, that's p of t. Okay, so that's p of t. This will be t divided by t squared minus 9. And this thing over here is q of t. Okay, so q of t is equal to e to the t over t squared minus 9. All right? And the theorem is very simple. The theorem says, look, this initial value problem has a unique solution in some interval, provided that p of t and q of t are continuous functions, okay, in the interval containing the initial condition starting point. So in this case, t naught equals 2. Okay, so what do I need to understand? Well, this is continuous for all t not equal to plus or minus 3, right? Because I can't plug in plus or minus 3 down here. I get a 0 in the denominator, so that's not good. And the same thing here. So this is the exact same thing. T squared minus 9 can't be 0, same denominator. Okay, so this one's also continuous for all t not equal to plus or minus 3. So here's the trick. It's very simple, okay? You just give yourself a real number line, okay? You give yourself the whole number line. You throw away the points t equals plus or minus 3. Okay, so I'm going to throw away minus 3, and I'm going to throw away 3. Okay, those are not allowed. And then you go and you find the input for your initial value problem. So your t naught is equal to 2. You find that on here, okay? You hope that it's not negative 3 or 3, otherwise you're in trouble. So if t naught's equal to 2, let's do that here. So t naught equals 2. Then you just say which of these three intervals contains t naught is equal to 2. And clearly this is the right one. So what is the interval? What's the largest interval on which solutions exist and are unique for this ODE? There it is, negative 3 to 3. Okay, it contains the initial condition, t naught is equal to 2. All of our functions, p of t and q of t, are continuous in this range. And so the theorem for this that underlies this example, the theorem states that solutions will exist and they are unique on the interval from negative 3 to 3. Okay, it's that simple. All right, you just play this game for every single first order ODE initial value problem, and you'll get the corresponding interval of existence and uniqueness. All right. Okay, so hopefully this is helpful. Like, subscribe, share with your friends, comment down below. We'll keep going.